So you bought one of these Nidec 24H motors from AliExpress for quite a bit to complete the self-balancing Q project I've started, and you can't figure them out. I've looked all over the internet and I just can't find a data sheet. But after a few more tests and such, I kind of figured out how it worked, and I wanted to show you guys today. So here I've got it here, and I've got the pin headers, and I'm just gonna race through this. There's not really much to it, and then I'll get into the code. I've taken out these four in the middle because they're responsible for feedback, and one, feedback isn't really necessary if you're doing the same project as me, and two, no one really knows how they work. They're really complicated, so I don't really need them. So you can just pluck one out one at a time. It's pretty easy. First live, we have just hooked it up to 12 volts, and then the second live is actually connected to the start/stop pin. So you would want to just grab your blue pin and wrap it around the red one, solder that on. And the reason we do this is so it starts, but it has to be in a second one for timing reasons. You want this to go, the first one to be live and the motor to turn on before it actually starts, so use the second one. The first ground simply goes to the 12 volts. The second ground just grounds up with whatever microcontroller you're using. And then the green pin is responsible for direction. So if you had this, I believe if it's high, then it's clockwise. If it's low, it's counterclockwise. It's really simple. This one is brake, yeah, but I'm not really sure what you do with this one. I believe you're meant to brake before you change direction, but I haven't actually done that. But apparently it makes your motors last a little bit longer, but I don't think that's necessary. And then we have the yellow pin, which is the PWM pin. So here's the code. We have just some comments, nothing too special. And then we have some constants for the pins. PWM pin 3. This could be connected to any, whatever microcontroller you're using. For me, Nano. Pin that supports timer or PWM. That would be 3, 9 and 11 as far as I know on the Nano. There's probably a couple others. Then you got the direction pin. That can be anything. I've just placed it one away from the PWM, so if you wanted to sell this, it's easier. Then you've got the duty cycle percent. That is 20, the range of this is 20% to 100%. 100% being top speed and 20% being low speed. And then you've got the frequency hertz, which is 7.8 kilohertz. It could be within 500 hertz and 50 kilohertz, but I recommend just using this because I've tested this. And the reason that it's that exact is because it's easy to set for the timer, which is what the PWM uses. Then we set the PWM pin to output, direction pin output as well. Set it high so it's clockwise. Low would be counterclockwise. Then we're just configuring the timers. Nothing you really need to know, and there's no dynamic changes, so no need for a loop. Okay, now here's the free motor test, and there's going to be less comments, and it's going to be probably a little bit more confusing. I haven't cleaned it up properly, but you'll understand. Now that you understand the basics of one, this should be more simple. So just got the same things here. We're now using 2 different timers, 2 different prescalers. You'd use 3, you'd use this timer, and then we'd set one for D9, and then D11 and D3 for the modes. And again, no loop. Anything I didn't answer that you still have a query on, just put it in the comments and I will answer it. Thanks.